product rule for derivatives. If you have two functions that are differentiable, then the product of the derivative is just the derivative of the first times the second plus the first times the derivative of the second. To begin with the proof, you simply apply the definition again. Here we have this difference over each. Now add 0 as usual in special form. So this quantity cancels. So you are adding 0 in special form. Just for our purpose. So in this case, you can separate these two together and these two together. Then you will have this. You factor out f of x plus h here. Here you factor out g of x. So you will get these two expressions. Now, applying product rule for limits. Just the limit of this existence below, say for a differentiable function. The limit is a continuous function. This is the ratio what you know for the derivative of g is a function. Here it's independent of course h, and here we have the ratio in the derivative of f. Now using the assumption, this product derivative is just the limit of this, limit of this, limit of this, and so on. But the limit of this is as h approaches 0 by substitution error, it is 0 here. So you'll have f of x. Here this is the derivative of g at x. Here g of x is independent of h. So it is like a constant. So the limit is itself. Therefore, finally, we have this is the definition of the derivative of f. Therefore, just plugging these values here. For this, f of x. For this, the derivative of g. For this, g of x as it is. And for this, the derivative of this. So we arrive at this conclusion. So this is the product. The quotient rule.